Hello and happy Thursday. Sorry that I'm not at school today. I am with the freshmen on their class council retreat, but I figured we could still learn some stuff about factored form through a video. So sitting in front of you, you should have the guided notes that Mr. Rude passed out. Today, our goal with these guided notes is to talk a little bit more about factoring quadratics and to also start using what's called factored form of a quadratic. So up at the top, you will see a space for factored form. So the first thing I'm going to do is write down what factored form is, and then we're going to come in together and we'll talk about what each piece means. So go ahead and write down factored form. It looks like y equals a. This a is the vertical dilation, just like it was on the vertex form and on the standard form. Now, x minus r1 and x minus r2, these are things that are called factors. And what's unique about them is that this r1 and r2, these things are called roots of the equation. So x equals r1 and x equals r2 are my roots. Now, what's special about roots, I'll make a little note over here, is that roots are the solutions to the equation y equals 0. So when I take an equation and I set y equal to 0 and I solve it, that my answers are what I call roots. Now if these roots happen to be real numbers, so if r1 and r2 are real numbers, then I can even go a step further and I can talk about them as x-intercepts. So my x-intercepts would be r1, 0, and r2, 0. So notice that roots and x-intercepts are the same thing as long as the roots are real numbers. Now we are only going to see real numbers today. We will not see what are called imaginary numbers until next week. So for now, you should always be able to call them x-intercepts. All right, so next up, why does factored form help us find these roots? So let's go back and just think about when we talk about roots. Roots, we said, were the solutions to the equation y equals 0. So if I take my factored form equation and I set y equal to 0, what we should remember from Algebra 1 is that we can solve this equation by using what's called the zero product property, or maybe you called it the ZPP. The zero product property tells me if I have a product, meaning I'm multiplying two factors together, and together their product is 0, one of them has to be 0. So maybe the first one is what I set equal to 0. I add r1 to both sides and I get x equals r1, so there's one of my solutions. But it's also possible that the second one was what equaled 0. I add r2 to the other side and I get x equals r2. So those are my two roots, my solutions to this equation. So the zero product property, along with factoring, will help us identify roots. So now let's see that in action. So we're going to do a couple of examples together where we are going to practice writing in factored form and we're going to practice finding roots. Now we are not going to do all of these examples. I will be doing part A, C, and E with you, and I'm going to leave B, D, and F for you to try on your own. The answer key is already posted on the website, so if you want to try them tonight, you should be able to check them. All right, so let's look at part A. Can we start by writing the equation in factored form? So remember what factored form looks like. I'll just put it right up here so we can see it. So factored form has multiple factors. It also has a coefficient out front. So notice there's nothing in front of these x's. So the first thing I'm going to do on part A is I'm going to see how I can factor it. Now this is a binomial because there's two terms. It's not a difference of squares, so what I'm going to look for is the greatest common factor. So between these two terms, the greatest common factor is a 3x. When I look at what's left over, I have an x minus 4. Now, technically, this is factored form, but if it doesn't quite look right to you, you can always rewrite this x like x minus 0, because x and x minus 0 are the same. That might help you really start to recognize what the roots are. So now, to find the roots, I set y equal to 0. Because it's been factored, I'm going to use the zero product property to take each factor and set each factor equal to 0. So if my first factor was 0, I get x equals 0. If my second factor was 0, I get x equals 4. So my two roots were x equals 0 and x equals 4. All right, that one was pretty easy. So now let's try one that's a little bit harder to factor, part C. So this is a trinomial. We spent time factoring trinomials yesterday. So the way I'm going to factor this trinomial is I'm going to look for two numbers that multiply to negative 42 and add up to 1. So these two numbers must be positive 7 and negative 6. Notice that A is still in front, it's just a 1. Now I'm going to go ahead and set it equal to 0, because if I want to find the roots, I set my factored form equation equal to 0. And now I get to take each one of my factors and set them each equal to 0. If I set the first one equal to 0, I get negative 7. So that's one of my roots. If I set the second one equal to 0, I get 6. So there's my second root. Quadratic functions should always have two roots. So if you ever find yourself only getting one, I will double check the work that you did. All right, let's try the last one together, part E. So this one is also a trinomial, but what we notice about it is that the leading coefficient is not 1, and it's also not a greatest common factor. So we're going to have to do this one by the method we saw on Tuesday or Wednesday called factoring by grouping. So remember with factoring by grouping, I keep the first term exactly what it was. I keep the last term exactly what it was, but instead of writing the middle term, I'm going to try to find two numbers that multiply to negative 10 and add up to give me 9. Well, two numbers that multiply to negative 10 and add up to 9 must be positive 10 and negative 1. So instead of writing positive 9x, I'm going to use positive 10x and negative 1x. Now I'm ready to group my terms, so I group the first two together. When I see the second one has a negative in front of the x, I like to keep that negative with the x, so I'm going to put a plus in the middle, because I'm not multiplying these yet. All I'm doing is grouping them. Now looking at my first group, I see what they both have in common. Well, they both have a 2x, so I factor out a 2x and I get left x plus 5. For my second group, they both have a negative 1, and I have left an x plus 5. At this point in factoring by grouping, between your two groups, you should always have a factor in common. So my factor in common is x plus 5. When I look at what's left over, I have a 2x minus 1. Now this is not quite factored form. Remember, factored form is supposed to have a coefficient out front. And right now, I have a 2 in front of the x. Factored form does not have numbers in front of the x. So we're going to have to do just a little bit more factoring to make this so it doesn't have a 2. So the way that I'm going to take out that 2 is I'm going to factor a 2 from my second factor. So if I take out a 2, I get left an x minus a half. The way that I can check this to see if I factored correctly is I can distribute that 2 back in. I would get 2x minus 1. So yeah, I did it right. So factored form, I like to put the 2 in front, x plus 5, x minus a half. There I am in factored form. Now I'm ready to set y equal to 0. As soon as I set y equal to 0, I can identify my two roots because they come from my two factors. So if I solve the first one, I get x equals negative 5. And if I solve the second one, I get x equals a half. So those are my two roots. So I would encourage you to try the other three problems, B, D, and F, on your own time. I would try them maybe before you start homework for tonight. All right, let's go ahead and move on to the back page. So on the back, we have a couple different examples. So the first one, we have a function g of x, and we are asked to find the roots and then to find the vertex. Well, let's start with finding the roots. We know that to find the roots, we first want to factor, and then we want to set it equal to 0. This is a trinomial, so we should be comfortable factoring this now. I'm going to look for two numbers that multiply to -8 and add to 2. So those two numbers must be +4 and -2. Now that I'm in factored form, I set my y value equal to 0. I use the zero product property to take each one of my factors and set them equal to 0. So if I set the first one equal to 0, I would get that x is -4. If I set the second one equal to 0, I get 2. So my two roots are x equals -4 and x equals 2. Now part B, can we find the vertex? I'm going to show you two different methods. So method number 1 is actually a method that we already saw. Method 1 we saw when we learned about standard form, and it was using -b/2a to find the x-coordinate of the vertex. Because my equation was written in standard form, I know that b is 2. I know that a is 1. So if I plug in that b is 2 and a is 1, I get -2/2. I get -1. So that is the x-coordinate of my vertex. If I want the y-coordinate, I go to my function g, I plug in a 1 everywhere I see an x, and I get -9. If you want to make yourself a note, just show we took the function g, we plugged in 1. So there's my vertex. Now that method was pretty easy because we were in standard form, but I want to show you a second method. And this second method is even easier if you know the x-intercepts. So if you know the x-intercepts, think about where the vertex should be. Now I'm going to sketch a picture. You don't need to draw it. We're just going to look at it together. Here's one x-intercept at -4. Here's another one at 2. I know this parabola is upward facing. And if I make my sketch, what I notice about my vertex is that it's halfway between my x-intercepts. So if I want to figure out what this x-coordinate is, I can average my x-intercepts. So I'm going to take my first x-intercept, add it to my second one, divide by 2. I get -2/2. I get -1. That is the x-coordinate of my vertex. Now to find the y, I have to plug it back into my original function, and again, I get -9. So either way, we were able to find the vertex. So now, just kind of thinking about all that we've learned the last couple of days, when you're in vertex form, you can easily find the vertex. When you're in standard form, you can use -b/2a. And when you're in factored form, you can average the x-intercepts. So we now have 3 different ways of finding the vertex depending on what information we know. All right, I'm going to go ahead and have the video end. We still have 2 examples left. So go ahead and stop this video and start up the next one, and I'll see you at example 3.